Welcome to my first video on statistics. The purpose of this video is to talk about standard deviation, which is one of the first few topics that come up when you're studying statistics in high school or in undergraduate university. So when I teach statistics at La Trobe, many students come up to me asking about what standard deviation is. And what usually happens is that they get bogged down in calculating standard deviation and they fail to understand what it actually tells us and what's the purpose, what is the benefit of this whole concept of standard deviation. What usually happens is that they go up to their text and that they find out that there is this formula that represents standard deviation. Now there's a lot of things happening in this formula. There's this square root sign, there's this summation sign, and inside these parentheses there's x with a subscript of I, there's a capitalized x with a bar at the top, the whole thing is squared, and then you're dividing everything by n, and in the end all of this becomes equal to this Greek symbol which is called sigma. Now this calculation is possible, of course, and many students actually they successfully do this calculation and they find out the standard deviation when asked to, but they fail to understand what the whole thing is. Why are they doing this? What's the point? And what are the benefits of finding standard deviation? So this video is not going to be mathematical. Now standard deviation itself tells you the deviation. That's what the name suggests, right? That's what it's supposed to tell you. It tells us how scattered, how spread out the data is, how much of a fluctuation there is in your data. So let's take an example. Let me just show it to you. Let's say I have two classes. There's a class 1 and there's a class 2. Let's say there's only 5 students in both these classes. And I take a quiz, and the quiz is out of 10. And this is how the students have scored. 7, student 2 scores a 6, then 8, then 5, and then 7 again. And in class 2, the scores go like this. Like there's one student scoring a 1, and then a 0, then somebody scores a 9 and a 10, and then somebody scores a 5. Now you can clearly, very easily tell the difference between the scores in these two classes. The numbers here are very close to each other. They're kind of clustered, while here the numbers are they're like all over the place. Somebody scoring a 1, a 0 on one extreme, somebody scoring a 9 and 10 on the other extreme. There's one student with a 5 in the middle. So it's very easy to tell actually that the standard deviation here in class 2 is higher than the standard deviation here. That's what standard deviation tells us. Without any without any calculation, I could tell this. We can actually find out what standard deviation is here in both the cases, but you can tell by just looking at the data how much of a deviation there is. Now, what's the benefit? Coming to the second question, what is the benefit of standard deviation? Let's take another example. So there's this famous example of crossing a river. So let's say you are asked that, let's say you're here and you're asked, can you cross a river that is on average 4 feet deep? On average, it is 4 feet deep. It doesn't mean that it's 4 feet deep at every point. It can be, but it can be there can be a scenario. Let's say I divide this river into 2 halves, and it's possible that it's only 1 foot deep here and it is 7 feet deep on the second half. While there's another, so let's say this is scenario 1. There's another scenario in which the river is 4 and 4 feet deep on both the halves, right? Both are 4 feet. Now, the standard deviation in the first case must be very high, we know, because the numbers are too far apart. Although the average is still 4, average is 4 here as well, but these two numbers do not fluctuate at all. So the standard deviation here is literally 0, while the standard deviation here, we don't know what exactly it might be, and we can calculate it with the formula, but it is definitely higher than 0, it's greater than 0, and it's higher than in this case. So the answer actually is that it depends on the standard deviation. Can you cross the river if it's on average 4 feet deep? Well, if the standard deviation of the depth is very high, then would most probably be very difficult to cross the river. But if it's low, something close to 0, then yes, certainly everybody should be able to cross it as long as they're taller than 4 feet. All right, so that concludes this short video. Thank you very much for watching. Goodbye.